Okay, here we're going to look and review ions and exactly what this is. So I want to spend a little time on this slide right here. We see a neutral hydrogen atom. This is not an ion. It's got one proton, one electron, one positive charge, one negative charge. Therefore, one proton, one electron, its net charge would be 0, would be neutral. And this notation would just be hydrogen. Now, if that hydrogen loses an electron, it is going to become positive because it has one positive proton, no negative charges. Therefore, it takes on a positive 1 charge, being noted as H+. That was what we would call a cation. It's a positive ion. Contrast to that, we have our neutral hydrogen atom here, and we add an electron. So now we have 2 electrons and 1 proton. Now we have 1 positive charge and 2 negative charges. The net charge on this would be a -1. That'd be H negative is how to be noted. That'd be called an anion. It's a negative ion there. So let's look at this a little bit more. Here's the same slide I showed you here. So an ion is an atom or group of atoms that has a net positive or negative charge. So again, that ion referring to something that has a charge. Neutral would just be called an atom. Atoms can gain or lose electrons to form ions. An ion is an atom with a charge. That's your kind of take-home summary right there. Recall that atoms are neutral in charge. If an electron is lost, the overall charge is positive. And if an electron is gained, an atom becomes negative. So initially this does confuse students. Losing an electron becomes positive. Well, an electron, keep in mind, is a negative charge. For losing a negative charge, the overall charge, therefore, is positive. Or sometimes it's easier to think of it the other way. If an electron is gained, if an atom is gaining a negative charge, it's itself going to become negative. We see that in our example here. Is the same thing on the title slide. Now, ions and atomic radius. So we're looking at atomic radius here. When electrons are lost, the radius becomes smaller. When electrons are gained, the radius becomes larger. So we see that here. We see our ions is the dark gray here. And here we're losing an electron. Therefore, if we're losing an electron, the radius will become smaller. Potassium, which is represented by K+ here, its neutral atom would be this large blue area. When it loses the electron, the radius becomes smaller. And we see that here, it's smaller radius. Contrast to that here are nonmetals. Let's take chlorine, for example. Neutral atom here is that kind of tannish region. When it gains, the radius becomes larger. So it's gaining an electron. That ion, that negative ion, that anion here is larger than the neutral atom. So that's how our atomic radius changes based on the ion that these elements may form. Showing how that may look here, positive cation formation when an atom loses electrons. Radius always becomes smaller because the loss of a valence electron can leave an empty outer orbital, resulting in a smaller radius. Electrostatic repulsion decreases, allowing the electrons to be pulled closer to the radius. So how does that look here? We see here our outer shell, valence electron has 1. We remove that electron, creating a +1 charge, and we see just visually right here, there's a change and a reduction in the radius of that particular atom. We see that here for kind of giving you group 1, group 2, and group 13, how the ion in red is smaller than the neutral atom represented in gray. And we see how those trends occur here in the periodic table. Continuing on, we have a negative ion or an anion formation. When atoms gain electrons, the radius always increases, which is sometimes contrary. And like, well, why does this occur? More electrons mean more electrostatic repulsion, resulting in an increase in the diameter here. So we have more negative charges out here, is a -1. More electrons out there. Think of just more space that they need. So therefore, the radius on an anion, the negative charge, will increase over the neutral atom. We see that trend developed here also in the periodic table. Here's the neutral atom, and then here's our ions that are forming in blue. We see overall all of those are larger. The anions are larger radius than their neutral atom.